To properly address your concern about the National Electrical Code question on page 263, additional information is required. Specifically, the exact wording of the question and all the answer choices are needed. This is because the National Electrical Code is a complex document, and the correct answer often depends on subtle nuances in the wording of the question and the specific context it presents. Without knowing the exact question, it's impossible to determine why the provided answer D seems incorrect to you or what misunderstanding might be occurring. Providing the question and answer options allows for a thorough review of the applicable National Electrical Code sections and related tables to determine the correct answer and explain the reasoning behind it. This involves careful consideration of factors such as voltage levels, conductor types, ampacity, dating factors, overcurrent protection requirements, grounding and bonding configurations, and applicable exceptions. Each of these factors plays a critical role in ensuring the safety and proper operation of electrical systems. Let's consider a few examples to illustrate how these factors can influence the correct answer. Suppose the question involves calculating the minimum size conductor required for a specific load. The National Electrical Code provides detailed tables such as Table 310.15 B16, which lists the allowable ampacities of insulated conductors based on their size and insulation type. However, the allowable ampacity must be adjusted for factors such as the ambient temperature and the number of current carrying conductors in a raceway or cable. These adjustments are outlined in National Electrical Code sections 310.15 B2 and 310.15 B3 respectively. If these adjustment factors are not properly applied, the calculated conductor size may be too small, resulting in overheating and potential fire hazards. As another example, consider a question involving the selection of an appropriate overcurrent protection device, such as a circuit breaker or fuse. The National Electrical Code specifies the maximum allowable overcurrent protection for different types of conductors and equipment. For instance, Section 240.4 provides rules for the protection of conductors, while other sections address the protection of specific types of equipment, such as motors and transformers. Selecting an overcurrent protection device that is too large can allow excessive current to flow through the circuit, potentially damaging the conductors or equipment. Conversely, selecting an overcurrent protection device that is too small can cause nuisance tripping, interrupting the power supply unnecessarily. Furthermore, the National Electrical Code contains numerous exceptions to its general rules, which can further complicate the selection process. For example, Section 210.21 B1 provides specific rules for the rating of receptacles, stating that a 15 amp receptacle on a 20 amp circuit is permitted in certain situations. Understanding these exceptions is crucial for applying the National Electrical Code correctly. To provide a more concrete illustration, let's hypothesize a question related to grounding and bonding. The National Electrical Code Article 250 covers grounding and bonding requirements, which are essential for preventing electrical shock hazards and ensuring the proper operation of electrical equipment. Suppose the question asks about the correct size of the equipment grounding conductor for a circuit. The size of the equipment grounding conductor is determined by the size of the overcurrent protection device protecting the circuit, as specified in National Electrical Code Table 250.122. Failing to select the correct size of equipment grounding conductor can compromise the safety of the electrical system and increase the risk of electrical shock. In addition to these examples, other factors that can influence the correct answer to a National Electrical Code question include the type of wiring method used, the location of the installation, and the presence of hazardous materials. Therefore, a thorough understanding of the National Electrical Code and the ability to apply its rules correctly are essential for electrical professionals. The National Electrical Code is updated every 3 years to reflect changes in technology and best practices. It is important to stay current with the latest edition of the National Electrical Code to ensure that electrical installations are safe and compliant. To assist you effectively, please provide the exact wording of the question on page 263, along with all the answer choices. With this information, I can analyze the question, identify the relevant National Electrical Code sections, and explain the reasoning behind the correct answer. Providing the specific context of the question allows me to provide targeted guidance and help you understand the underlying principles of the National Electrical Code. For instance, if the question involves calculating voltage drop, I can walk you through the steps involved in performing the calculation, including selecting the appropriate formula and using the correct values for conductor resistance and impedance. If the question involves selecting the correct type of wiring method for a particular application, I can explain the different types of wiring methods available and the factors that should be considered when making a selection. Without the specific question, I can only provide general information about the National Electrical Code. Once you provide the question and answer options, I can provide a detailed explanation of the correct answer and help you understand any misunderstandings you may have. It is important to consult the National Electrical Code directly for the most accurate and up-to-date information. The National Electrical Code is a complex and comprehensive document, and it is essential to have a thorough understanding of its provisions to ensure the safety and proper operation of electrical systems. Remember that electrical work should only be performed by qualified and licensed individuals. Working with electricity can be dangerous, and it is important to take all necessary precautions to avoid electrical shock and other hazards. The National Electrical Code is a valuable resource for electrical professionals, but it is not a substitute for proper training and experience. If you are not a qualified electrician, you should not attempt to perform electrical work. Please provide the question and answers so I can further assist you.